Yes, sir.
Okay. So now, so today the topic is new topic, unit 2 of your electrochemistry, that is reversible and irreversible cells. This is the first class of your unit 2. The unit 2 title is reversible and irreversible cells. So in this today, these are the concepts I will going to discuss with you people. First one, because this is a first class, so introduction is very important. Then based on the introduction, reversible and irreversible cells I will discuss with you people. Then after this, the reversible and irreversible electrode. So here, the interconnection between these three concepts. One is introduction. Because of the introduction, with the help of the introduction, we are discuss the reversible and irreversible cells. Then, based on the reversible and irreversible cells, we are going to discuss the electrodes of these reversible and irreversible cells. Okay, so yeah, the concept one is the reversible and irreversible potential. Then introduction. So yeah, the electrochemistry is completely basic things. What is that? Here electrode is there, the flow of electricity here through the solution, the one from one side to another side, the migration of ions are there. So cations migrate to the anode, and then anion migrates to the cathode, like this. So this is complete information. The conductors or conductance, all the things are we are going to discuss now. Here, just you see, the flow of electricity through solution of electrolytes is due to the migration of ions. When potential difference is applied between the two electrodes, the cations, which are positively charged ions, move towards the negatively charged electrode known as cathode, will anions, which are negatively charged ions, towards the positively charged electrode known as cathode. This is the complete fundamental of the electrochemistry. The has with the which electricity flow through the solution, through a solution, is called a conductance. We are representing G in this case of the solution. It is defined as the reciprocal of the resistance. The definition of conductance is reciprocal of resistance of the solution. The resistance we are representing R. Then what is that? In we are representing this conductance. G is equal to, G stands for a conductance, reciprocal of resistance 1 divided by half. It is expressed in unit called reciprocal ohm or ohm inverse, like this, or SI system of unit is conductance or Siemens. We are representing this S, capital S. Then generally this is also very fundamental to you people. Why? Because the galvanic cell, well known example for this reversible cells. So what is that galvanic cell? We are already very familiar. In the introduction class also I discussed that the last unit. So galvanic cell, yeah, the combination of two electrodes dipped in its own ionic solution. Generally, we are taking copper electrode and then zinc electrode. Zinc electrode acts as an anode, copper electrode acts as a cathode because of its electrochemical series. Zinc in the upper, then after this, copper is lower. And then the electrode potential value of zinc is very less when compared to copper. Okay, the negative electrode species of zinc, then it release electron faster than compared to the copper. That's why here a galvanic cell is a device in which a free energy of a physical or a chemical process is converted into electrical energy. We know the concept, which such as usually consists of two electrodes emerged in one or more suitable electrolytes put up when an electrodes are connected externally as well as internally if required. A chemical reaction occurs. What type of chemical reaction occurs? Zinc acts as anode, copper acts as cathode. We know why, because electrochemical series it's very less, more active, then more electrode potential value, less active, least active. So that's why one acts as anode, then second one acts as a cathode. Okay, based on this equation, based on this explanation, we are going to discuss the reversible cell. What is that reversible cell? Here, very simple. The reversible and irreversible cell we are going to discuss. what are the properties, what are the conditions we want to know in this reversible cell? In thermodynamics, a reversible process is defined as a process in which, what are those? Yeah, the driving force is infinitesimally different from the opposing force. The conditions. Just you see, reversible and irreversible cells. What are the things are there? Yeah, first one. In a thermodynamics, we are giving more importance for these reversible cells. A reversible process is defined as a process in which one, a driving force is infinitesimally different from the opposing force. The second case, the process can be reversed by applying for infinitesimally greater than the force already acting. So, if you want to reverse the cell, so what we are going to give, how much energy it gives, how much potential it gives, so greater than that you supply the external force, external source of current, then it will reverse the cell reaction, or the cell completely reverse. This is the two condition. The concept of reversible process, which highly significant in thermodynamic, a number of relationships have been derived for the process that are thermodynamically reversible. So again he explained this, the concept of reversible process which highly significant. Why? Because it is having a thermodynamic a number of relations have been derived with the help of this reversible and irreversible process, derived so many relations we're going to derive for the process that are thermodynamically reversible. In a cell, chemical energy is converted into electrical energy. We know that is the chemical energy converted into electrical energy. It's a Daniell cell or a galvanic cell. In order to that of a thermodynamic relation may be applicable to cells, the cell must be operate under reversible condition. So some parameters are there, that parameters it obeys, then we are called that type of cell, that is a reversible cell. So that conditions it obeys, that obey which cell obeys those conditions, that is called a reversible cells. What are the conditions, what are the parameters we are observed here? Here first one, the driving force and opposing force are difference very slightly from each other. So two cells are there. We know one half cell is a zinc, another half cell is copper, zinc, and then copper cells. Copper two half cells are there. The two half cell made up of one single cell. Okay. Next, here what is that? The first point is the driving force and opposing force. Driving force and opposing force are difference very slightly from each other. The next one, driving force and opposing force. One is it produces some movement of electron from one side to another side. Here, one force. Then when we are applying that force, slightly greater than what it produced, that much amount, that energy, slightly greater than the cell produced in a amount of current. So what happened? It is the point number one. The driving force and opposing force are different very slightly from each other. Second case, it is possible to reverse the cell reaction by applying slight excess of external EMF. Sorry, that is a problem. Applying slight excess, that is a slight axis. So that typing mistake. Yeah, it is possible to reverse the cell reaction by applying slight excess of external EMF. Then it is reversed. We are going to give some amount, excess amount of energy. For example, 1.01 volt it produced, the Daniell cell produced 1.01 volt in 1 molar concentration of the cell, or electrolyte concentration 1.01 volt it produced. So what we are going to give, it we are giving external source greater than that 1.01. So what happened? That cell reverse automatically, reverse reaction we are getting. So this is the meaning of your second condition. It is possible to reverse the cell reaction by applying slight excess of external EMF, then we are getting the reverse cell reaction. Next, the third case, if an external EMF, sorry, yeah, the external EMF, which is equal to the EMF of cell is supplied, then the cell reaction must stop. So what is that? It's very, very meaningful. If a external EMF, here external EMF, which is equal to EMF of a cell is supplied, then the cell reaction must stop. Why? Because both are same, equilibrium established. There is no movement of electron from one cell to another side. So what happened? The cell reaction completely stop. This is the meaning of the third condition. Then fourth one, it must produce very small current. It must produce very small current. So these are the conditions obeys in any cell. The cells we are generally called reversible cell. Okay, if a cell does not satisfy above conditions, it's said to be a reversible. Here they're not satisfied on the time what we are going to call that is a reversible cell. If a cell does not satisfy, it's not satisfy the above condition, it's said to be a reversible cell. Next, here another one, a cell is said to be irreversible if the cell reaction does not remains always in the state of equilibrium. It is not obeys. A cell is said to be irreversible if the cell reaction does not remains always in a state of equilibrium. So it is not equilibrium. Irreversible in the sense it is movement. The movement of electron or ions one cell to another cell, it will move, then there is no equilibrium established in the cell. That cell we are generally called irreversible cell. The first one is reversible, so which is not obey this process on the time, that is a reversible, then it obeys, then it will not remain equilibrium, that is irreversible cell. So these are the conditions of reversible and then irreversible process. Next, after this, we are taking a reversible cell explanation. The best example for this reversible cell, Daniel cell, is a well-known example for reversible cell. Just you see the Daniel cell. We are already discussed this Daniel cell. Zinc rod dipped in zinc sulfate solution, copper rod dipped in copper sulfate solution, externally connected through voltmeter, and then internally connected through salt bridge. Then what happened? The movement of electron from zinc side to copper side through voltmeter. Then the ions move through the salt bridge with the help of the salt bridge. Internally, we are going to connect through the salt bridge. So what happened? The cell reaction is reversible. So how it is reversible? So one is moving electron from outer circuit, then ion from this side to this side, inner circuit, that salt through salt bridge. Then what happened when we take 1 mole of zinc sulfate and 1 mole of copper sulfate solution? The EMF of cell is it produce 1.01 volt at 25 degrees centigrade. Zinc rod is dipped in zinc sulfate solution. Copper rod dipped in copper sulfate solution. In its copper sulfate solution are connected externally through a conductor. Then the electron flow through the outer circuit from zinc electrode to copper electrode. Then here, what type of reaction taking place? Here you see the cell reaction, zinc oxidation takes place. Zinc gives rise to Zn2 plus 2 number of electron it releases. Then second one, copper, it will take the produced electron from the zinc side, it will reduction taking place. So Cu2 plus 2 number of electron gives rise to Cu. The net reaction taking place in this cell, the Daniel cell, Zn plus Cu2 plus gives rise to the arrow mark, very important arrow mark. So what it tells? The arrow mark tells the reversible. So one direction is forward, another one is backward direction. What it tells? It is a reversible process exists. Okay, it is a reversible process or reversible cell, it tells. So then Zn2 plus Cu. So both you take on anode reaction, it is also a reversible. Then cathode reaction, it is also a reversible. Then we go to the point when we are going to observe the point. If you give more than the 1.01 volt, what happened? The cell are completely reversed. Why? Because how much amount of energy it produce? It produce 1.01 volt. If you give slightly excess of this much of slightly excess of volt from externally, so what happened? For example, 1.05 or 1.10 volt you give, into this cell, what happened? The cell is exactly reverse. That's why we are called this one as a reversible cell. All of you getting this point, I think. Okay, the reversible process, it's a very simple. It is reversible. It will, first one, it is equilibrium established. Next one, you give slightly excess of the external source, then the cell is completely reversible. It exits reversible. Okay, so this is the linear cell. Then if an external EMF is applied, which is equal to EMF of cell 1.01 volt, the cell reaction is stopped. Again, the same thing. If you apply excess of or slightly greater than that EMF 1.01 volt, then the reaction get reversed. The reaction gets reversed. So this is the concept. Then what happens if it is reverse? The net cell react completely reverse. The net cell is equation 1. You see, Zn plus Cu2 plus gives rise to Zn2 plus Cu. If you apply like this, then that is completely reverse of the equation number reaction 1. Then Cu copper plus Zn2 plus gives rise to Cu2 plus Zn. We are getting this reaction when we are applying slightly greater than the greater than the voltage of the cell or cell potential or cell EMF. Then if the current flowing in the opposite direction, then the cell reaction is exactly reverse of the previous one equation. Okay, so opposite direction, exactly we are getting this equation. Now if we apply external EMF less than the EMF of the cell, less than 1.01 volt, then the reaction 1 can be restored. Again, we are getting the same reaction what we are getting the equation number 1 or reaction number 1. Again it will restored when we apply less than 1.01 volt, so can be restored. Hence these type of cells are referred as reversible cell. So now maybe you got the information about this reversible cell. Any doubt about this reversible cell, guys? Any idea you got? Any you getting some information? No, reversible cell meaning concept. Can I move to the another concept?
Yes, sir.
Okay. So next concept, irreversible manner, irreversible cell. What is that irreversible cell? Here just you see the representation of the cell, zinc rod and then copper rod. We are dipping in a solution. That solution or electrolyte is only a single electrolyte. H2SO4 we are taking. Then we are dipping two electrode inside the cell or a beaker. That beaker containing H2SO4. Okay. Then the movement of ions from zinc side to anode side taking place. Then what type of reaction? Just you see this. This is the representation of the cell of a reversible cell. Zn bar H2SO4 is the electrolyte aqueous solution. Then copper is an electrode. Consider a cell composed of zinc and copper electrodes immersed in a solution. That solution is H2SO4 solution. Then two electrodes connected externally by a wire. The following reaction taking place. What type of reaction taking place? First one is zinc. Why? Because it's a less electrode potential value. Then the reaction is faster. Zn. This Zn reacts with H2SO4, Zn2 plus actually. The Zn2 plus reacts with H2SO4, H plus HSO4 minus, or here SO4 minus, SO4 2 minus. Then it reacts with Zn2 plus, it forms ZnSO4, zinc sulfate formation. Then it liberates hydrogen gas. It liberates hydrogen gas. So this is the first reaction. Then if an external EMF slightly greater than that of the cell will applied, the following reaction taking place. What happen if you give external reaction into the cell? Again, same as your previous concept, it produce some amount of volt. You give more than this, more than that, for example it produce 0.5 volt, you give zero point 0.6 volt. So what happen? Yeah, the reverse reaction taking place. Reverse is nothing but another electrode reaction is first, then the zinc reaction is later. Okay, Cu plus H2SO4. This reaction CuSO4 plus hydrogen, liberation of hydrogen gas, which is not reverse. What happened? It is not reverse. Zinc sulfate again it converting into Zn2 plus H2SO4. It not possible. It is not possible. So that's why if you give excess EMF to the cell, what happened? Another electrode reaction is faster. in compared to the actual reaction. So, which is not reverse of the original reaction. Therefore, such a cell is not reversible and thermodynamic principle cannot be applied to it. Hence, this is irreversible cell. We are called this type of cell we are called irreversible cell. So, you getting the information or you getting information about this cell, this explanation. What is that irreversible cell? If you apply external EMF to the cell will not reverse its reaction or its original reaction. Okay, that is called irreversible reaction or irreversible cell. Okay, for example, I will take this one. This is a first reaction. If you are not applied any external EMF into the cell, this is the reaction taking place in the cell. Zn plus H2SO4 gives rise to ZnSO plus SO4 plus liberation of hydrogen gas or evolution of hydrogen gas. This is actual reaction. If you apply slight excess of EMF into the cell, what happen? If it is a reversible cell, then ZnSO4 plus H2 again it reverse. Zn2 plus H2SO4 it forms, but it is not possible in this cell. That's why we are called this one as a irreversible cell. If you give extra or external EMF into the cell, what happen? Another electrode is there. That electrode reaction is first or carried out like this. Cu plus H2SO4 gives rise to CuSO4 plus liberation of hydrogen gas. So this is happen in the cell when we are applying external EMF into the cell. So this is the reaction. Then the reversible and reversible electrode. So this is the concept reversible cell. Are you getting the concept of irreversible electrode, guys? Irreversible cell, guys? Can I move to the next concept? Are you getting the? Okay.
Yes,
Next,
sir.
after this, the electrode process. So the first concept is reversible cell. Second one is irreversible cell. Then third one is reversible electrode. We are generally called non-polarizable electrode. What is this polarizable? I will tell you later. Why? Because one particular topic is there in your syllabus, polarization. In the particular concept, I will explain later. Okay, what is that polarization, polarizability? Okay, I will discuss non-polarization, polarization, all the things. Reversible electrode. What is this reversible electrode? Again, we have to discuss some introduction about this reversible electrode. In electron, that was its potential of its charges, unit charges of a reversible nature. In contrast, two electrodes used in electroplating and destroyed during their use. After this, they are going to destroy. Battery we are taking, best example, a reversible galvanic cell consists of two reversible electrodes, one which acts as a cathode and another acts as anode. Electrode along with electrolyte reagent associated with it. It's called opcell, and the reaction that occurs in opcell that's called a opcell reaction. So this is the introduction. A reversible electrode. What is that reversible? Where we are using this reversible electrode? If the electrode is reversible, what happen? We will not destroy that electrodes again and again. Okay, we can use the same electrode for further application or further utilization. Okay, yeah. What are the types of electrodes are there? So we know the concept of cells. So for example, you take Daniel cell, anode of cell, cathode of cell, or zinc of cell, then copper of cell we are getting. So generally we are taking of cell reaction and reversible electrode. Metal ion electrodes we know. Metal ion. What is that metal ion, guys? So metal ion. Zinc is a metal. Zinc sulfate is the ion, metal ion electrode. So that is the of cell. Then copper sulfate is a metal ion, Cu2 plus. So this is the type of electrode. So we are called metal ion electrodes. Then gas electrode. So then the gas electrode is nothing but hydrogen electrode. Again, three types of gas electrodes are there: hydrogen electrode, chlorine electrode, oxygen electrodes are there. Then third one, metal insoluble metal salt electrode. So what are those? We are using reference electrodes. So one is metal insoluble salt means calomel electrode. Then Ag bar AgCl electrode. That is one silver chloride electrode, is a reference electrode using in a glass electrode for the determination of pH. Then calomel electrode, so determination of pH or estimation of pH, estimation of potential, what generally we are called this one as a uh, potentiometric estimation of iron, Fe2 plus. Okay, so there we are using calomel electrode as a reference electrode. So this is the best example for metal insoluble metal salt electrodes. So this is metal insoluble metal salt electrode. Two examples are there. Metal insoluble metal salt. So one is calomel electrode. Mercury is there. Mercury is the metal. Then mercurous chloride is the insoluble metal salt. Mercurous chloride. So that is in the calomel electrode. So this is the one example. Second one for this metal insoluble metal salt, uh, here silver is the metal, then silver chloride is the insoluble salt, insoluble metal salt. So that is also a better example for the third electrode of electrode of cell reaction and a reversible electrode. Then oxidation reduction electrode. So already we know that is this electrode we can use the potential determination of the iron Fe2 plus. So determination or estimation of the potential of or potentiometric estimation of the iron. We are using this for platinum electrode. So platinum electrode, what happen? Oxidation and reduction both taking place in a single electrode. That's why we are called this one as a oxidation reduction electrode. Generally, we are called these type of electrode. Platinum electrode we can use platinum electrode. Okay. Here these are the four different types of electrode we are observed, reversible electrodes. Then we are discuss this. The electrodes of a reversible cell are called reversible electrodes. Very simple concept. What is that reversible electrode? What are the electrodes we are using in reversible cells? All the electrodes we are called or we are considering reversible electrodes. Each electrode is termed as a reversible electrode because of an off-cell reaction occurring at the electrode can take place in the direct direction as well as the reverse direction. Just we are going to uh, check the one by one, check this electrode process or electrode reaction, what happened. So now it's very simple concept, very simple meaning. What is that? The electrodes of a reversible cell are called a reversible electrode. The definition: each electrode is termed as a reversible electrode because the off-cell reaction occurring at the electrode can take place in the direct direction as well as reverse direction. Okay. So point number one: metal salt. Just you see Ag bar AgNO3 electrode. So this type of reaction taking place. Ag gives rise to Ag plus plus electron minus. Then reverse also taking place. When we are applying the external EMF, then this reaction easily reverse. So this type of reaction, that's why we are called this one as a reversible electrode process or electrode. Then second one is metal salt. So copper sulfate electrode. Then if you apply external EMF into the cell, what happen? This reaction completely reversible. Okay. Oxidation, it will show oxidation initially. If you apply external EMF, then it is reduction reaction it will show. Then mercurous chloride, calomel electrode. So again, this is also, these many electrodes are there. These electrodes were generally called reversible electrode. Reversible electrodes. All of you getting this point? Are you getting this point? Reversible electrode? Any doubt? Okay,
No,
fine.
sir.
Next, the properties. Any electrodes, if it is a reverse, then having some properties. What are those properties? It allows exchange of charged particles between two phases, between electron and solution phases. So it will allow a exchange of charged particles. So that is the reversible electrode property. It allows exchange of charged particles between the two phases. What are those two phases? solution phase and then electrode phase. So two phases. Then second one is reversible electrode reach a state of equilibrium. The discharge of ions and their reformation takes place at the same rate. So this is the second property obeys the reversible electrode. Reversible electrode reach a state of equilibrium. The discharge of ions and their reformation, discharge of ion again reformation takes place at the same time. It will discharge and then it will reform. Both it will takes place in the same time. Equilibrium established. So this process is taking place in the reversible electrodes. Then third one, there is no net current flow, no network is done, or the magnitude of the current passage is so minute that the electrons are not sensibly disturbed from their equilibrium condition. If you are not supplying any external source, no net current flow, or there is no magnitude of current passing through the solution, it will not disturb where in the electrode to the solution. So solution, what is that, establish the layer, double layer, it will not disturb. Okay, so this is the another property of this. There is no net current flow, no network is done, or the magnitude of the current passing is so minute that the electrons are not sensibly disturbed from their equilibrium conditions. This is the third condition of the reversible electrode. Then the electrode potential remains constant. Electrode potential is, for example, what is that, zinc. So zinc minus 0.76 volt, that the electrode potential will remain constant. You can use wherever. Okay, in any cells you can use the electrode potential value of that particular electrode, that is constant. Okay, it will not change its electrode potential or original electrode potential. These are the important properties of the reversible electrodes. The next, then what are the properties of irreversible electrodes? Here, it does not allow the exchange of charged particle from one phase to another phase. So this is very important concept. Properties of irreversible is exactly opposite of the reversible electrodes. What is that? It is allow the exchange of charged particle in the reversible electrode, but it is completely opposite. It does not allow the exchange of charged particle from one phase to another phase, electrode phase to solution phase. It will not allow. Okay, that is irreversible electrode. The second one is no electrochemical equilibrium is established. The rate of discharge of ions not equal to the rate of reformation of ion. One fast, another slow. One is faster, another one is slow. So it is not equilibrium established. It will not establish the equilibrium in its cell. Okay, so this is the second one. Then third property, since there is no net current flow across the electrode solution interface, so there is no work is done. If it is very important. The net current is very essential in this. If it is not possible, then there is no work is done in the cell, where in irreversible cell or irreversible electrodes. Okay, since there is no net current flow across the electrode solution interface, so there is no work is done. That is the irreversible electrode, as well as in irreversible cell also. Next, then fourth one, the electrode potential where is ordinary by means of external voltage. What is that? The electrode potential where is ordinary by means of external voltage. It is varies this potential for electrode potential. Okay, that is the voltage variation. The means of external voltage, it will vary its value or potential value. But reversible electrode, it is not. It is completely constant. Okay, so these are the important discussion what we are observed today. Reversible cell, irreversible cell, reversible electrode, irreversible electrode. So these are the important discussion today. If you have any doubt, you ask the question. I will clear your doubts. Any doubts about this, guys? What we discuss? very important and meaningful concept we are discussing. We are discussed today. Any doubt you ask the question, please, about the today concept, or can I explain once again?
Okay, sir.
Okay.